Good morning. So today we're going to review your rules of exponents, simplifying monomials, combining like terms, scientific notation, graphing exponential functions, growth and decay, and sequences, geometric sequences. So this is all for your Unit 6 test that you're going to have. So rules of exponents, remember, if you have like bases, okay, if you have like bases, you can add the exponents, okay, and you're multiplying them together, okay. If you are going to raise, my power rule, if you're going to raise an exponent to another power, remember you can multiply those exponents, okay. If you are going to divide like bases, we subtract the exponents, okay? Remember, anything to the 0 power is always a 1, and if I have a negative exponent, we can make it positive by moving it to the denominator, okay? All right, let's do some examples here. Okay, so let's do these examples here. Alrighty, so if I say x squared times x to the 6th, I am going to add those two exponents. So that's going to be x to the 8th power. Sorry. Okay, over here I've got xy cubed times xy raised to the 4th power. So the first thing I need to do is simplify the power. So that's going to be, remember you multiply, so it's going to be x to the 1 times 4, so it's going to be x to the 4th, and y to the 1 times 4, which will be y to the 4th. And now we'll multiply our like bases. So remember that's an understood 1 on that x. So now I'm going to say x to the 1 plus 4, which is 5, and then y to the 3 plus 4, which is a 7. Okay? So here we're going to raise each one to the power, so it's going to be 2 cubed. Okay, so x to the 3 times 3, which is a 9, and y to the 2 times 3, which is a 6. 2 cubed is going to give you an 8. Okay. All right, so what about a negative 3 squared? So it's a negative 3 squared. X to the 3 times 2, which is a 6, and y squared. So negative 3 squared is going to be a positive 9, x to the 6th, y squared. Okay, let's do some more. So here I've got 3x to the 6th y over 12x cubed y squared. So I would simplify the fraction, so 3 over 12, and this will be x to the 6th minus a 3, and then y to the 1st minus a 2. So the fraction 3 over 12 will reduce to a 1/4. This will be x to the 3rd, y to the negative 1st power. Remember, we don't like negative exponents, so we're going to move that negative to the bottom. So this is going to now be an x cubed over 4, because that 4 still stays there. And we're going to move the y to the denominator. Okay? Alrighty, so let's look at number 6 here. So number 6, I've got something raised to the 2nd power. So I've got x to the negative 4th raised to the 2nd power. So I need to multiply those. So this is going to be 16 x to the negative 8. I need to do that before I can do my first step on number 5. Okay, and then I'm going to have a 4 times x to the negative 3 times negative 2, which is a positive 6. Okay, so 16 over 4, and then x to the negative 8 minus a 6. So 16 over 4 is going to be a 4. Okay, it's going to be x to the negative 14. So this is going to be 4 over x to the 14th power. let's do one more here. Okay, so here, this is from your practice test. So we need to multiply, so this is going to be a 3/4 times x to the 7th times x to the 5th is going to be x to the 12th power. And y to the 6th times y to the 9th, so you'll add those exponents, so that'll be y to the 15th power. Okay, so over here we'll say 1/2 cubed, so 1/2 cubed is going to be a 1/8. Okay, then you multiply, so x to the 12th and y to the 15th power. Now we have to find our common. Now we can add our like terms because those are in common. So I've got 3/4 minus 1/8. Okay, so I'm going to be able to combine these because they are the same. So remember, we do not touch the exponents when we're adding. Okay, so what we're going to say is 3/4 minus a 1/8. To do that, we have to get a common denominator. So our common denominator is 8. So this is going to be a 6 minus a 1/8. And remember, we don't touch those two. So this is going to be a 5/8 x to the 12th, y to the 15th power. Okay, so just a few more combining our like terms. Remember, to combine our like terms, to add and subtract monomials, it have to be like terms. And those two are like terms. So we can say 7 minus 8, so it's going to be a -1 xy, which is, remember, the same thing as negative xy. Okay, here these are the like terms here. So they both have, we've got an xy squared and we've got an xy squared, so we can say 2 minus 4, which is a -2 xy squared. Okay. If you had a trapezoid here, the area of a trapezoid, whoopsie, the area of a trapezoid would be very close to the triangle, but the area here is going to be 1/2, not just your base now, but the top plus your base times your height. Okay? Alright, so let's do some examples here. So, if I wanted to find, let's find the perimeter and the area of this one. So find the perimeter and the area of the rectangle. Okay, so the perimeter would be to add up all the sides. So we would say 2 times your length, which will be 4x squared y, plus 2 times your width, which is going to be your 8x. Okay, so you'll have 8x squared y plus a 16x. And you can't combine the like terms there, so that'll be your perimeter formula. Your area will be your length times your width, so 4x squared y times 8x. So this will be a 32x cubed y. Okay, let's look over here at the area. Let's find the area of this figure, this trapezoid here. So it's going to be 1/2 times that 2xy plus 8xy, and then I'm going to multiply it times 3x squared. Okay, so that's going to be 1/2 times 2xy plus 8xy is going to be a 10xy. Multiply it by 3x squared. So now you'll have a 1/2 times 30x cubed y. Half of 30 is going to be a 15. So this is going to be a 15x cubed y for your area. Okay, so now we're going to talk about scientific notation. So remember, scientific notation takes small numbers and large numbers, and you can rewrite it. So if I had this number, and I wanted to write it in scientific notation, remember you would move your decimal. So you're going to move it to the left. 1, 2, 3, 4, 5, 6, 7. So this is going to be 7.8 times 10 to the 7th power. It's a positive, right? So how many places do we move? 1, 2, 3, 4, 5, 6, 7. Okay. Alrighty. What about taking a number and taking it out of scientific notation? So if it was 4.2 times 10 to the -3rd power. Okay, so this is a very small number. So if I was going to take this out of scientific notation, okay, you're going to move your decimal place 1, 2, 3. 3 places to the left here. So your answer here would be 0.0042. Okay. Remember, when you add numbers that are in scientific notation, that you have to have the exponent on the tens, okay, on the base 10 has to be the same. Okay, so if I was going to add, let's say we're going to add 9.1 times 10 to the -3rd plus 5.8 times 10 to the -2nd power. Can't add those right there because they're not in the same. They're not in the same form. They don't. I've got 10 to the -3rd and I've got 10 to the -2nd. Okay, so I need to make, say, 0.91 times 10 to the -2nd plus 5.8 times 10 to the -2nd. If I was to add those now, say 0.91 plus 5.8, so that's going to be, what, a 6.71. Okay, when you multiply scientific notations, okay, then you will multiply the numbers and then you will add your exponents. Okay, so let's take this one here. So this one's 5.6 times 10 to the 4th times 4.5 times 10 to the 6th. Okay, so I'm going to multiply. So I'm going to multiply 5.6 times 4.5. Okay, and then I'm going to say times 10 to the 4 plus 6, or 4 times, to the 10 to the 4th plus a 6, which will be 10 to the 10th. So 5.6 times 4.5 is going to be what, 25? 25.2. Okay, but that's not in scientific notation. So that's to the 10th power, so I need to move my decimal. So I need to make this 2.52 and add 1 to my exponent. Okay? Alright. Okay, so now let's do some exponential growth and decay. So exponential growth and decay, remember, we would graph this by plugging in values for your x. Okay, so remember here, this y equals, I'm going to number these. This is going to be my 1 and this is going to be my 2. So y equals 3x minus 4. So that 3 is greater than 1. So this is going to be a growth. My 2, my base is a 1/4, and 1/4 is less than 1. So this one is going to be a decay. Okay. Domains for both. Okay, remember it's going to be all real numbers. So that means when I graph, because the rest of it I'm going to have to graph, looking at, okay, then you can plug in all values for your x. Okay, any value you want to for x. We always try to do -2, -1, 0, 1, and 2. Okay, for both of these. Okay, so for the first one, you plug in a -2, 3 to the -2, so it's going to be 1/9 minus a 4, so that's going to be at -3.8, -1, okay, so that's going to be 1/3 minus a 1, so it's going to be -3.6, okay, 0, if you plug a 0 in there, you're going to get a -3. If you plug a 1 in there, you're going to get a -1. If you plug a 2 in there, 3 squared minus a 4, which gives you a 5. Okay, so here, the range is going to get, as you get your exponent, it gets smaller and smaller and smaller. You're getting close to some value of a -4. So your range here is going to have to be, y is going to have to be greater than -4. Okay, it's always going to be greater than 2. Okay, the intercept, you found it down here, so we always like to plug in a 0. So your intercept is going to be 0, -3. Okay, and your asymptote is the same thing, basically as your range here. So it's going to be y equals a -4. So that means it's going to get close and close to that value, but it's never going to touch that value. Okay? All right, let's look at the fraction one over here for number 2. So if you plug in a -2, so you'll say 1/4 to the -2nd power. So that's going to be an 8. So that will be a, oops. Okay. If you plug in a -1, so that's going to be a 2. If you plug in a 0, you're going to have a 1/2. If you plug in a 1, you're going to have a 1/8, which is a 0.125. If you plug in a 2, you're going to have 1/32, so it's going to be 0.03125. Okay, so as my x value here, because this is a decay problem, because remember, let's do this real quick. Growth, growth would mean that my exponential function would look something like this. This would be a growth function, okay? Decay would mean that it's going to look and flatten out down here, okay? So for a decay, so for this decay here, as my x values get larger, I'm flattening out, okay? So as my x values get larger, I'm flattening out, and I'm flattening to the y value of a 0, okay? So my range here is going to be y is going to be greater than a 0, okay? My intercept, we always find it, is going to be 0 and 0.5. And then my asymptote here is going to be y equals 0. Okay, so a decay as your x value, you flatten out. A growth as your x value increases, you're growing, right? So you're flattening out as your x values get negative. Okay, so that's what's important there for your exponential growth and decay. Okay. Okay, so applications to growth and decay. Remember, we have two formulas, but really they're the identical formulas, and the reason that they're different is because one has a plus sign and one has this minus sign here. Okay, the plus sign means that you are going to have a growth, and then the minus sign means that you would have a decay, so you would have a decrease. Okay, so you would have a decrease in your rate. So something that would be decreasing at an exponential rate. Okay. All right, so remember your A is your initial, so your A is your starting point. Okay, your R is your growth rate. And your T is your time. Okay. Okay, let's do an example here. So I bought a home for $180,000. Value increases at 3% each year. Find the value after 10 years. Okay, so my initial starting point is going to be 180,000. My rate is increasing, so it's going to be a positive. It's going to be 3%. Remember, we can't use percentages. We turn that into a decimal. And my time is going to be 10 years. Okay, so my formula here would be 180 times 1 minus 0.03 plus, raised to the 10th power. So it's going to be 180,000 times 1.03 raised to the 10th power. Okay, when you multiply that out, should be what, 242. Okay, so geometric sequences are our other thing that we talked about. So remember the formula to find the sequence? Okay, so to find your geometric sequence, you have to know what your first term is. Okay, so it's going to say A1 times your R, and your R, remember, is your ratio, and you're going to raise that to the n minus 1. Okay, so your A1 is your first term. So just like the growth rate, and your R is your ratio here. Okay. All right, so if I wanted to find the ratio, -4, 20, -100. Okay, so we would divide, remember, so we would take -100 divided by 20, so that ratio there would be a -5. And same thing, 20 divided by -4 would also be a -5. So my ratio there would be a -5. Okay, let's say if I wanted to find a to the 7th power, or the 7th term, okay? So if I wanted to find the 7th term, I would say -4 times -5 raised to the 7 minus 1. So -5 raised to the 6th power times a -4. So the 7th term is going to be 62,500. Okay? And that is everything that you need to know for your test. Okay? All right. Hope you have a great day.